Okay, so now we'll move on to the next part of our lesson. The next part is where we integrate. So they say here the method for integrating hyperbolic expressions is usually the same as that we applied for the corresponding trigonometric expressions. So you have already learned how to integrate in the P3 book. In P3 integration, you learn how to integrate, especially you learn how to integrate the trigonometric functions. So here we are learning now how to, we are learning how to integrate the hyperbolic functions further. So they say here the methods we use are almost exactly the same. So they say many hyperbolic functions can be integrated by recognizing that they are of the form f dash x fx to the power n or f dash x over fx. So basically the last two rules of our integration. Okay, so by using these two rules, many of the many integration questions can be solved quite easily. Okay, so let's see what we are talking about here. So we'll start with exercise 4b. Let's start with the first question. Exercise 4b, question number 1. Let's start with part A. Integration of sine cube x cos x dx. So now you all know when it comes to integration, the rules are very strict. We need to, if we are trying to integrate, the rules need to look exactly the same. It needs to look exactly the same as what they have given, right? So these are the integration rules that we have learned. So you can see in these rules, there's nothing called integration of sine cube x cos x. There's nothing like that, right? So basically, they have told us when we get some product like this, what do we do when they don't look like one of these rules? We can try using one of the two rules that I mentioned earlier: f dash x fx to the power n or f dash x over fx. Which one do you think works? So do you see here there is this sine x has a power of 3. So therefore, what do we understand here? So we can think of this sine x as the person with the fx to the power n. So this is the power fx to the power n. And then I have cos x in front. Okay, now remind me again. So if sine x is my fx, then what's the differentiation? Because you know this is supposed to be f dash x, right? The rule we are using is f dash x fx to the power n. Which means what? We have the differentiation of the inside function outside here. So what is the differentiation of sine x? Do I have the exact perfect differentiation of sine x out here? Yes, I have cos x exactly because sine differentiation is cos. Isn't it? Sine differentiation is cos. I have the differentiation rules also here. Here, d by dx of sine x is cos x. So f dash x is perfectly there here. So I have the perfect f dash x. And I have the fx here. So then let's integrate. When you integrate, what do you get? You add 1 to the power of your fx, right? Fx to the power n plus 1 divided by n plus 1. Don't forget the plus c. So when I integrate this, what do I get? I get here sine x to the power 4 divided by 4 plus c. So that's it. Basically, in other words, this is what I get. Okay, so let's try these sums. Try a few more. So part B, integration of tanh 4x. So what happens here? So when it comes to integration of tanh 4x, again you can see that I don't have integration of tan. Okay, here I have the integration of tanh 4x given immediately, right? Okay, so we can use that. Let's use it. Okay, so then yeah, we can use this rule also. Yeah, tan x is ln cos x. However, we have tan 4x, which means what? If you have tan 4x, you have to use the ax plus b rule. So when you have ax plus b, you're going to remember when you are integrating, you have 1 over a. Okay, so when you are integrating. Okay, so this was f dash ax plus b. When we integrate f dash ax plus b, we get 1 over a f ax plus b. The general rule. Okay, so when you have any coefficient with x, we need to make sure we divide with it. So tan 4x will give me tan x integration is ln cos x. So tan 4x will give me what does it give me? Tan 4 ln cos 4x, but that's not all. 1 over 4 ln cos 4x. So the answer is equal to 1 over 4 ln cos 4x. Try the next one and don't forget the plus c. Part C, integration of tan to the power 5x sec square x dx. Okay, what do we do here now? Definitely we don't have any rule like this, right? Definitely there's no rule that looks like this in a formula, in our formula. Okay, so what do we do here? So now you can see here tan also has the power and the sec also has the power. However, just go through the differentiation of tan. If you go through the different, now I have the differentiation rules here. Can you see? The differentiation, the d by dx is the differentiation rule. When you go through the differentiation of tan x, what do you see here? Do you see it's set square? So that means, do you see that we can actually use this f dash x fx to the power n rule? Which means what? How do I arrange this to f dash x fx to the power n format? Keep the set square x in front and tan x to the power 5. The tan x is our fx. Look at it. That when the tan x is your fx, then when you differentiate tan x, you get set square. So you see, and this power 5 can be your n, because basically in f dash x fx to the power n can be anything. N can be any power. Okay, so here because there's this power 5 of tan, it becomes the n. Then I only need to be bothered with the differentiation of tan, which is here. The differentiation of tan is set square, which we have here perfectly. Okay, so then I have the perfect f dash x. And this is the fx to the power n. So I can integrate this immediately. So the rule is we add 1 to the power of fx, right? The answer becomes tan x to the power 6 over 6 plus c. That's it. Okay, then the next question. Cos h to the power 7x cot x. Try that. Cos h to the power 7x into cot x dx. Okay, so how do we differentiate? How do we integrate this? Think about it. So in this case, when we try to integrate this, now we know we need to use one of the two rules, f dash x fx to the power n, right? Basically, none of these rules will immediately work, right? So what I'll do here is I'll break this guy, the cos h to the power 7, we'll break this as cos h to the power 6x times cos hx into cot x. Is this okay? Yeah. Basically, there's power 7, so I took 6 of it together and one of them here. Okay, then the cos hx cot x, if you take them together, you all can see the cos hx to the, I know how to, I know the diff now. I'm going to use f dash x fx to the power n rule, right? So obviously when there is a power here, this person has to be my fx to the power n. Do you get me? This has to be my fx to the power n. So my power n should be 6 here. And my fx is cos hx. And look, when you now, this, the other part has to be that when you differentiate the cos hx, right? So can you say differentiation of cos hx gives me minus cos hx cot x, but actually I have the main elements here. So look again, let me rearrange and show it to you properly. So I'll rearrange and write it. This is cos hx cot x, okay? Into, then I have here cos hx to the power 6. Let me write it like this. So basically what I'm trying to say here is that cos hx is my fx. The fx to the power n. Okay, this is my fx to the power n. And then f dash x is when you differentiate cos hx, right? So differentiation of cos hx, can you see it's minus cos h cot? And you can see I have most of the things here. Cos h cot is there. The only thing that's missing is what? The minus sign. The only thing I'm missing is the minus sign. So what I'll do is I'll input a negative sign here. And also I'll put a minus sign outside also. Because in that way it balances it balances it out. Okay. Yeah. So then this is my what? Now this entire thing is my f dash x. So f dash x, fx to the power n is there perfectly now. So outside there's a minus 1, just leave it there, let the minus 1 be there. So minus 1 is there, and when you integrate, what happens? We add 1 to the power of fx, right? So minus 1 times fx is cos hx to the power, you add 1. 7 divided by 7 plus c. So if I rearrange again, it's minus cos h to the power 7x over 7 plus c. Can you all understand? Part E, integration of root cos 2x sine 2x. So basically, again, you need to understand the root is there. So when you have a different sort of a power, then your head needs to go, okay, this should be my fx. Because there is a power half here for the cos 2x. Do you see? So then in here, I'll keep the sine 2x in front. And then the cos 2x. So because there is a power half here, I feel like this should be my fx. And half is my power n. And then, so what's the differentiation of cos 2x? Do we know the differentiation of cos 2x? Cos x differentiation is sin x. So when it's cos 2x, what's the differentiation? You remember the product chain rule, right? So cos 2x is sin 2x into 2. So then what is missing here? We have the sin 2x. The only thing we are missing here is the 2, because we need the f dash x needs to have 2 sin 2x. So then to cancel off the 2, if you are putting a 2, you have to put a half to cancel the effect. Okay, so then let's integrate. So I'm using the rule, once again, I'm using the rule f dash x into fx to the power n. So when I integrate, it becomes fx to the power n plus 1 over n plus 1 plus c. Okay, so then in here we have half times, so add 1. So you can see this is your f dash x, right? And this is your fx. Do you see it? So what happens here? I end up getting here half times cos 2x to the power half plus 1 is 3 over 2 divided by 3 over 2 plus c. So then half divided by 3 over 2. Yeah, 2 and 2 cancels and I end up getting 1 over 3 cos 3 over 2x, cos to the power 3 over 2x plus c. Okay, so I think it's, sorry, cos 2x. Let me write it in a better way. 1 over 3 cos 2x to the power 3 over 2 plus c. 1 over 2. Sorry, it's 1 over 3. Then, yeah, the half 1 over 2 and 3 over 2 they are divides, and you get half divided by 3 over 2 is 1 over 3. Okay. Then move on to part F. Sec to the power 10, 3x tanh 3x. Sec to the power 10, 3x times tanh 3x. So then, once again, you need to realize there's a power 10 for sec, which means what? That needs to be our fx to the power n. So then you need to immediately think, okay, this is my fx, which means we need to have the differentiation of sec x outside. So what's the differentiation of sec? It's sec tanh. So there is a sec and a tanh. So you can see having a tanh is not enough. We need another sec. Therefore, the sec to the power 10, we need to break it as what? Sec to the power 9, 3x into another sec 3x times tanh 3x. We need to break it. Because we realize there's a power here and this person, probably this person should be our fx. Okay, so then let's rearrange again. I'll keep the sec 3x, tanh 3x in front. And then here I have sec 3x to the power 9. So basically what I mean is this is my fx to the power n. So fx is sec 3x. So f dash x is, you need to realize is if it's 3x, the chain rule works. So it's minus sec 3x, tanh 3x into 3. Okay, because it's 3x here. So then what is missing here? We have sec 3x, tanh 3x. We are missing the minus sign, and also don't forget we are missing a 3 because we multiply into 3 because it's 3x. So to make the complete f dash x, I am missing a minus 3. Along with the minus 3, it becomes a perfect f dash. So to cancel it out, I have to put a minus 1 over 3 outside. So now I have the perfect f dash x. So then we can integrate now. So minus 1 over 3 stays out. The fx is sech 3x to the power 9 plus 1 is 10 divided by 10. And don't forget the plus. The final answer will be minus 1 over 30 sech 3x to the power 10, or we can write sech to the power 10 3x plus c. Okay, so that's it. Okay, moving on to question number 2, part A. Integration of sin x over 2 plus 3 cos x. Okay, so now to do this one, again, you can see this looks nothing like any of the rules we have learned about, right? So then definitely you need to realize if it does not look like any of the rules we learned about, we have to go into one of these two formats, f dash x fx to the power n, or f dash x over fx. So then how do we choose the correct one? Now you can see here we have sin x in the numerator and 2 plus 3 cos x in the denominator. Shall we just, I think it has a look, it looks like we can use rule number, the f dash x over fx. Shall we try it? So look, the fx is the denominator. And what do we need to do here? The differentiation of the denominator needs to be perfectly there in the numerator. So do we have it? 2 differentiation is 0. 3 times cos x differentiation is what? Cos differentiation is sin. So then it's 3 cos x. So 3 cos x differentiation is 3 sin x. So you can see do I have the differentiation perfectly? No. We are missing a 3 because the 3 cos x differentiation is not just but 3 sin x. So there is a 3 missing. So then we'll input the 3 here to make the perfect f dash x on top. When you input the 3 outside, you have to put a 1 over 3 to cancel that effect. So now I have the perfect f dash x over fx. So now we use this rule. So what's the answer? 1 over 3 times ln 2 plus 3 cos x plus c. Okay. Then we'll move on to the next one. I took part C. In part C, integration of 5 cos x plus 2 sin x over cos x. Okay, so how do we do this one? So basically now, in this one, don't go to f dash x over fx immediately. You fail. The first thing you should do here is to separate. Yeah. Okay, so separate the two people here. So I get here integration 5 cos x over cos x. What happens? 5 cos x over cos x becomes 5. Plus here I get 2 sin x over cos x. Do you see? So when I simplify this, I get 5 plus 2 sin x over cos x is tan x. So now, do we know the integration of, so just anyway integrating constant is simply, so integrating 5 a constant with respect to x is 5x. Integration of tan x is also given, right, in our rules. Integration of tan x is given here. Tan x integration is ln cos x. Can you see? So answer is 5x plus 2 times ln cos x. And don't forget the plus c. Okay, then let's move on to the next one, third one. Let's go to the third one. Question number 3. They're asking you to show that integration of cot x dx is equal to ln sin x. Okay, they're asking you to show it. Okay, so how do we show it? The integration of cot x, no, it's not given. So how do we show that the integration of cot x is ln sin x? So what we do here is we break the cot x. So what is cot? Cos over sin. Cos x over sin x. So it's like the cot x in trigonometric form. Cot x is cos over sin. Similarly, cot x is cos x over sin x. So now, what rule am I going to use? So I can use the f dash x over fx. Your fx is sin x. You know, sin differentiation is directly what? Your fx is sin x. Your f dash x is cos x. So basically we get here what? ln sin x plus c, which is what they wanted, ln sin x plus c, to show that. Moving on to part B, show that the integration of cot 2x from 1 to 2, they have given you integration limits. Okay, so if it's cot 2x, what do you think will be the changes happening here? So suggest me the changes happening here. It will be, what are the changes? It will be, first of all, there's a 2 here, yeah, 2x. So then with the a, if you have a ax, you divide 1 over a. So basically, if it's 2x here, we definitely get 1 over 2 and ln sin 2x. And there's no c here because we have integration limits. We have the limits from 1 to 2. Let's input our integration limits and try to get the show that. So I get here half times ln sin, 2 times 2 is sin 4, minus half ln sin 2 times 1 is 2, 2 times 1 is 2. Okay, yeah, so this is ln sin 4 minus half ln sin 2. So all okay, yeah, we can take it as the subtraction of two logarithms. We can take it as a division. Half is common to both of them. ln sin 4 minus ln sin 2. Okay, I just wrote one extra step. So half subtraction of two logarithms is a division under a single logarithm. Sin 4 divided by sin 2. Now the thing is, they are asking us to get this, show that. Now you can see the show that has is in terms of the exponential e. So then what do we do here? Now don't go type sin 4 in the cal. You will not be able to get the show that. So what you do is use the hyperbolic definitions. So what's the definition for sin x? Sin x is e to the power x minus e to the power minus x over 2, right? This is the hyperbolic definition of sin x. So use that, equal half ln sin 4 will be e to the power 4 minus e to the power minus 4 over 2. And instead of writing this again like a big division and over, what I'll do is I'll put the division sign here. Divide by sin 2. This gives me e to the power 2 minus e to the power minus 2 over 2. So then division to multiplication, half ln e to the power 4 minus e to the power minus 4 over 2, division to multiplication. This becomes 2 over e to the power 2 minus e to the power minus 2. So then the 2 and 2 cancels. However, you can see I need to get the show that. The show that doesn't have e to the power 4. They have e square plus 1 over e square. So how do we simplify from this point onwards? Yeah, we can use difference of two squares. If you have a to the power 4 minus b to the power 4, you can write as it's a square minus b square. So it's actually a square minus b square times a square times b square. Just reminding you, how to use difference of two squares for a quartic power when there's a power 4. This is a simple a square minus b square rule, but it's with the power 4. So similarly here, e to the power 4, you can apply the rule here. How does it work? E to the power 2 minus e to the power minus 2 times e to the power 2 plus e to the power minus 2. Then into 1 over e to the power 2 minus e to the power minus 2. So what happens here? E to the power 2 minus e to the power minus 2 will cancel. And I have here half ln e square plus e to the power minus 2, which gives me what? Half ln e square plus 1 over e square. I think the show that has a root. They show root. So for the root, we can take the half inside as a power. So this is ln e square plus 1 over e square to the power half. So that's it. This is the root, the show that we get. Okay, so do you understand? Okay, then let's move to the next part. Okay, question number 4, they asked us to use integration by parts to find the integration of x sin 3x. Once again, it's quite similar to what you have learned in P4. So integration by parts you learned in P4. So in there, I have written the rule that we use. The integration of uv dash is equal to uv minus vu dash. So do you remember how v dash becomes v? V dash becomes v through what? Integration. V dash becomes v through integration, and u becomes u dash. From u to u dash, you have to differentiate. So that's it. So then basically what you have here is you have two variables. One variable you choose to differentiate. The other variable you choose to integrate. So u is the variable that you choose to differentiate because u becomes u dash here. Can you see? And v dash is the variable that you choose to integrate because v dash has become v here. So then you have two options here. So in P4, we have told you when both two options are there, and you can see one is x, the other one is shine 3x. So both these options we can differentiate, both of them we can integrate. When that is the case, we have told you to continuously differentiate and see the first person who becomes 0. That should be your u when both are differentiable and integratable. So you can see here x when I differentiate becomes 1 and 1 when we differentiate it becomes 0. So that is the first person to reach 0. While when you differentiate shine 3x, it becomes 3 cos 3x. Again, when you differentiate, you again get shine. Again, it becomes cos. So for shine, continuous differentiation will not make it 0. Okay, so this rule is only used when both are differentiable and integratable. Okay, so there might be questions where you don't have a choice. In that case, go for the one who can differentiate to differentiate, the one who can integrate to integrate. Here, both options are possible. So in that case, I will definitely choose the x to be u and the shine 3x to be v dash. Okay, so let's start. So let's start fourth one, part A. Integration of x shine 3x. So x will be my u, shine 3x will be my v dash. So u equals to x. So from u to u dash, you need to create u dash, right? So u dash becomes differentiation of x is 1. The next one is our v dash. V dash is shine 3x. Okay, v dash is shine 3x. So v dash to v, we integrate. So integration of shine 3x is 1 over 3 cos 3x. So now we have our v dash, u dash. It's time to just substitute everything into the equation. So integration of x shine 3x equals uv. So directly substitute to the equation. Who is u? U is x, v is 1 over 3 cos 3x. uv minus integration v u dash. U dash is into 1. Do you agree? So then I get here 1 over 3x cos 3x minus 1 over 3 comes out integration of cos 3x. So yeah, so integration. Now this one we don't need any extra help, right? Cos 3x we can immediately integrate. So then I get here 1 over 3x cos 3x minus 1 over 3 cos 3x integration is again 1 over 3 sine 3x. So basically 1 over 3 gives me 1 over 9 sine 3x. And don't forget the plus c. Similarly, let's do part B. Fifth one, part B, that is also exactly the same. Sorry, we'll do fourth one, part B. Fourth one, part B. Fourth one, part B, integration of x h square x. Integration of x h square x. Let's try this one also. So by the way, x, you can both differentiate and integrate. What about h square? I think h square you can see from rule number 4 in the integration. Do you see h square can be integrated? Yeah, so then we can go for h square as a v dash. Okay, x can be a u. So if one person completely, x can differentiate and become 0 very quickly. So when it becomes 0, if one person becomes 0 quickly, the integration finishes really fast. Okay, so then once again here, my u is x, which means u dash is 1, v dash is h square x, v is h square x, integration is tan x. Okay, so I'm doing the fourth one part. So let's do this one. So the answer is integration of x sec square x dx is equal to what? uv. So it's uv minus integration vu dash, right? So let's substitute u is x, v is tan x minus integration v is tan x into u dash is 1. So x tan x minus integration of tan x. So integration of tan x is given ln cos x plus c. So we are done with it. Can you see? Let's move on to fifth one, part B. Integration of e to the power minus 2x sine 3x. Okay, let's try this one. Okay, so I think you can see here that both of these functions are integratable, both of them are differentiable. Okay. However, is there anyone who becomes 0 really fast? You can see e2x when you differentiate, it keeps on, you don't, I mean, ex differentiation is ex. Ex differentiation is ex. It doesn't, it's not over. Shall we first start with fifth one, part A? Let's start with fifth one, part A, and then move on to part B. Fifth one, part A. It will be easier for you all to understand when I do fifth one, part A. Okay, so in fifth one, part A, okay, so let's start with this. Okay, so here you can see ex differentiation is ex. Ex integration is also ex. Cos x differentiation sin x. Cos x integration is also sin x. Is there anyone who becomes 0 first, or is there anyone who is ending this process very fast? No. So both of them are continuously differentiating and integrating. So in this case, both are differentiable, both are integratable, right? So we don't have, there's no, I mean, there's no preference here. You can go in any way you like. So let's go in, maybe we'll take ex as our u and cos x as our v dash. Even if you interchange and take, it's fine, okay? Because both are differentiable and both are integratable, okay? Are you listening to me? Then my u is ex, which means what is my u dash? Ex differentiation is ex. You remember the differentiation of ex? Efx is efx into f dash x. Ex equals ex differentiation is ex. V dash is cos x. V dash to v, integration of cos x is sin x. Okay, shall we apply the rules? So the integration rule is uv minus integration vu dash. Let's apply. So I get here uv, okay. Okay, so actually, yeah, I'm going to use integration by parts. However, I just, we can differentiate this, we can integrate this quite easily, right? There's another option where we can input cos x in terms of our hyperbolic definition for cos, and we can simplify and integrate quite easily anyway. So since I started the parts by differentiation, parts by integration, I'll continue with that, and then I'll show you how to do the easy method as well, okay? So let's go with the difficult method now, and we'll do the easy method as well afterwards. So ex, so this is u, v sin x, uv minus integration v, u dash is ex. Are you with me? Okay, so then this is the integration of ex cos x, right? Equals, here I get ex sin x. So you can see again I get a part where I have ex sin x integration. So now here there are again two people. So again two people means what? Again I have to go for parts by integration. So again I'll take, this is my u, I'll take, this is my v dash. So if u is ex, u dash is also ex. Here my v dash is sin x. My v different integration of sin is directly cos. Let's input the value here. So I'm trying to get the answer for the integration of ex cos x. So this is equal to, so far I have got ex sin x minus, let's put a big bracket here because we are about to put a, use integration by parts. U is ex, u v minus v u dash. U dash is ex. Okay. Sorry, uv minus vu dash with integration sign, right? Not just, but this comes with the integration. uv minus integration v u dash. Are you okay with it? This is with respect to x. Okay, let's open the bracket now. Integration of ex cos x dx equals, here I get ex sin x minus ex cos x. And do you see here minus minus becomes what? Plus, right? Okay. Okay, so I think this method doesn't work, right? I was trying to take this to the other side and add it with this. But ex cos x dx integration with the positive ex cos x dx, when I take it here, it cancels out, which means this particular question, it doesn't work with parts by integration. I was trying to add it and then make it to, I was trying to add and do it. But it doesn't work like that. So what we'll do is I will go in the other method that I suggested. What's the other method? Yeah, we will substitute the cos x with its hyperbolic definition. So ex cos x is what? E to the power x, e to the power x plus e to the power minus x over 2 dx. So now before we integrate, we will simplify inside. So I get here, I'll take the half out. Ex into ex is e2x plus ex into e minus x is e to the power 0, which is basically 1. So then we get, let's integrate here, half times integration of e to the power 2x is efx, eax plus b. Basically, it's 1 over ax plus b. Again, 1 over 2 e to the power 2x plus the integration of e to the power 0 is, e to the power 0 is 1. Integration of 1 is simply x. And don't forget the plus c. Okay, so we get here 1 over 4 e to the power 2x plus half x plus c. Okay, let's move on to part B. Fifth one, part B. Integration of, the question is integration of e to the power minus 2x sine 3x, right? So what do we get here? Again, it's best that we go with what? The definitions of the hyperbolic function. So what do we get here? Integration e to the power minus 2x sine. Okay, so sine 3x will be e to the power, what is it? E to the power 3x, right? Sine x is ex minus e minus x over 2. So sine 3x will be e to the power 3x minus e to the power minus 3x over 2. Okay, dx. So it will take the half out and multiply e to the power minus 2x is e to the power 3x is e to the power x minus e to the power minus 2x is e to the power minus 3x is e to the power minus 5x. Now we'll integrate half. E to the power x integration is e to the power x minus e to the power minus 5x is 1 over minus 5 e to the power minus 5x plus c. So we get half ex minus becomes plus 1 over 10 e to the power minus 5x plus c. So this is your answer. Okay. Question number 8, let's do part A. Now in question 8, they say to use appropriate identities. So the first one is the integration of sine square. So what are the identities that we learned? So basically these are the three main identities. The trigonometric converted to the hyperbolic and also the double angle rule. So these are the main identities we use to do all these questions. So the first one, to do integration of sine square. Do you think using the first identity cos square minus sine square, do you think that helps? So this is something we learned in even in P3, right? Integration of sine square, integration of cos square. So it doesn't work by using this because if we go for cos square, we still don't know how to integrate the cos. we don't know how to integrate the cos square. So then in this case, we always use the help of the cos double angle rules. It's similar to sine square. We use the help of the cos double angle rules. So where do we have sine square? You can see cos 2x is equal to 1 plus 2 sine square. This is okay. So then we'll use the equation cos 2x equals cos 2x equal 1 plus 2 sine square x, which means what? Make sine square x subject. So we get here cos 2x minus 1 over 2 equals to sine square x. Do you agree with me? Cos 2x minus 1 over 2 equals sine square x. So let's input the value here. So I'm going to integrate cos 2x minus 1 whole thing divided by 2. This is sine square x. Let me take the 2 out, the half times integration of cos 2x minus 1. So what do we get here? Half times integration of cos 2x is 1 over 2 sine 2x minus integration of 1 is x and then plus c. So basically 1 over 4 sine 2x minus half x plus c. Next one, part B, integration of sec x minus tan x square. So before we integrate, what do we need to do here? First we'll expand the brackets because we don't know how to integrate something like this. First we'll expand the bracket. I get here integration sec square x minus 2 sec x tan x plus tan square x. Okay, so this is what we get. So when we see the integration, okay, I think we can see we know the sec square integration is known. Can you see? We know how to integrate sec square. We know how to integrate sec x tan x also. However, the only thing that we don't know to integrate is we don't know how to integrate tan square. Can you see? So to integrate tan square, what do? We use the help of our identity. 1 minus tan square is equal to sec square. So let's use that because we don't have tan square integration in this list. Okay, so conversion tan square to sec square brings us to this list and we can integrate. Okay, so the rule I'm using is 1 minus tan square is equal to sec square. So 1 minus sec square is then equal to tan square. So let's input the values. Sec square x minus 2 sec x tan x plus tan square is 1 minus sec square x. The sec square will cancel. So I get here the integration of 1 minus 2 sec x tan x. Okay, so then the integration of 1 with respect to x is x minus 2 sec x tan x integration is minus sec x. So minus, there's a 2 here. 2 into minus sec x plus c. So I end up getting here x plus 2 sec x plus c. Let's go to the next one. Okay, part C, integration of cos square 3x over sine square 3x. Okay, so how do we do this? Integration of cos square over sine square, we can use cos square over sine square is actually what? It's cot square, right? Cot square 3x. Okay, now let's look at the rule. Do we know how to integrate cot square? No, however, we don't know how to integrate what? Cosec square. We don't know how to integrate cosec square. So then you can see here we have the rule for this 1 minus cot square x is minus cosec square x. So we can use this rule here. Let's use it. So I can modify the rule 1 minus cot square 3x is equal to minus cosec square 3x. If I make cot square 3x a subject, I get 1 plus cosec square 3x is equal to cot square 3x. Are you with me? So let's substitute that value here. Integration of 1 plus cos h square 3x. So let's input the value. The integration of 1 with respect to x is x. Cos h square 3x, you can see it's linear with the 3x here. So don't forget to put what? 1 over 3 cos h square integration is minus cot. Minus cot. So then here 1 over 3 into minus cot what? 3x. Okay, so this is the answer. Okay, now let's try part B. I think it's going to be more of a challenge. Integration of sine square x cos square x dx. Okay, how do we do this? You can use the same techniques you used in P4. Right? Okay, so sine square x cos square x integration, how do we do it? So we can use a technique similar to what we did in P4. So take the power 2 out from both of them, sine x, cos x, and we can take whole thing to the power 2. And then why am I doing this? Because we know the identity, what's the identity that we are going to use? Sine 2x is 2 sine x cos x. Basically, what I want to do here is, so if sine x cos x is what? Sine x cos x is, I can write as sine 2x over 2. Do you agree? Sine x cos x is, if I take the 2 to the other side, it's sine 2x whole thing over 2. I just took this 2 to the other side as a division. Okay, so let's input that. This is sine 2x over 2. So then don't forget outside there's a power 2. So then the power 2 will affect here. Inside it becomes sine square 2x. Over the 2 becomes a 4. Okay, so now again we have integration of sine square. So let me take that 1 over 4 out. So I have integration of sine square 2x. So how do we integrate sine square 2x? We previously did integration of just sine square x, right? When I have just sine square x, we use the help of cos double angle rule. Okay, so similarly here, when we have sine square 2x, you know the cos double angle rules. You can, I mean, if I have, now we wrote cos 2x is 1 plus 2 sine square x, right? Whatever the angle you have here, it's doubled on the other side. So if I have sine square 2x here, if I have sine square 2x here, this should be cos what? This should be cos 4x. Cos 4x is 1 plus 2 sine square 2x. So this is the identity that I'm planning to use. So this means sine square 2x is cos 4x minus 1 over 2 equals to sine square 2x. So let's input the value. 1 over 4 integration of sine square 2x is cos 4x minus 1 whole thing divided by 2. 1 over 4 into 1 over 2 is 1 over 8. Integration of cos 4x minus 1. So now let's integrate. So 1 over 8 cos 4x integration is 1 over 4 sine 4x. Minus 1 integration is minus x. Plus c. So 1 over 32. Okay, so this is the answer. Let's move on to the next one. Okay, next let's move on to part E, integration of cos to the power 5x. Okay, integration of cos to the power 5x dx. Okay, so how do we do this? Okay, so you know we can't integrate a cos to the power of 5. And can we use any of our rules f dash x fx to the power n also? No, to do that I need two functions. I need integration of cos sine. I need something like that. So there's nothing like that here also. Okay, so when we have something like this, the technique we use is a little bit different. So look, cos to the power 5x, I'm going to break it as, let's break it, it's going to be cos to the power 4x times cos 6. Do you agree with me? Okay, cos to the power 4x into cos x. Then cos to the power 4x is actually what? Cos square x, the square of it, right? Cos square x into another cos square x. Can you see the way I'm breaking the sum? So cos to the power 5x is eventually written as cos square x into cos square x into cos x. Now, what do we know about cos square x? Our identity. The identity is what? Cos square x minus sine square x equals to 1, right? Which means who is cos square x? 1 plus sine square x. Input the value 1 plus sine square x. Again, cos square x is 1 plus sine square x into cos x. Okay, so this guy I'm not doing anything. I'm just replacing the cos square x here with 1 plus sine square. Okay, now open these two brackets. 1 into 1 is 1. Plus 1 into sine square is sine square plus again 1 into sine square. So I get 2 sine square x plus sine square into sine square is sine to the power 4x. Folding times cos dx. Do you see the purpose of why I did like this? There's a reason. Actually, now you can see I can now input the cos x inside with each of these people. And now what's my plan? My plan is to use f dash x fx to the power n. Look. So I get here cos x, cos x. The next one I get 2 sine square x cos x. The next one I get sine to the power 4x cos x. Do you see that this is completely? I mean, we can now integrate these people, right? Using the rule f dash x fx to the power n. We can use this rule now. Okay, cos x of course is directly integratable. We don't need to fix anything here, but this one, 2, I will fix it here, 2 cos x. Do you see the sine square x is what I consider as my fx to the power n? And here cos x, the sine to the power 4x is what I consider as my fx. Okay, so in both these places, do you see I have fx and f dash x? Can you see? Sine x differentiation is cos x and you have an n here. So sine x is my fx, the power n is 4 here, this is f dash x. So I can perfectly use this rule, right? So according to this rule, we add 1 to the power and we divide. So let's do it here. Cos x integration is directly sine x. Plus this 2, was it necessary? Is this 2 part of our f dash x? Is this 2 part of our f dash x? No, the f dash x is only the cos x. So therefore the 2 will remain. Okay, otherwise the 2 will go with the cos, f dash x. Here the 2 is not part of the f dash. So 2, this is sine x to the power 3 over 3 plus here cos x is part of our f dash x. So adding 1 to fx, I get sine x to the power 5 over 5. Don't forget the plus c. So it's going to be sine x plus 2 over 3 sine cube x plus c. Okay, so can you see how to do integration sums of these things? You need to really familiarize yourself with these kinds of questions, even with Shine also, because definitely you will be seeing integration sums where you need to use these techniques. You must learn to use these methods in these questions. Okay, so please familiarize yourself with these techniques. Okay, so the next thing I want you all to learn is to know the integration of sech x. Okay, so this is not, you need to know to do the proof for the integration of sech x. So when it comes to sech x, you can see that we don't have the integration of sech x in our formula sheets, right? And we don't have it in the set of equations given. So none of the rules are working. So what I want to do for sech x is, okay, integration of sech x. You write the topic. Okay, so this you need to separately learn the technique. So what we do here is for sech x, we go back to the original, the hyperbolic values. So what was sech x? You know, Cosec's definition was Ex plus E minus X over 2, right? So Sech is the reciprocal of cos, which means what? 2 over Ex plus E minus X, right? So 2 over Ex plus E minus X. Shall we simplify this a little bit? Ex, E minus X means, you know, it's 1 over Ex. Shall I multiply both up and down with the Ex? Okay, then what do we get here? 2 Ex. Ex into Ex is E2x. E minus X into Ex is e to the power 0, which is 1. Okay, so I come to this point. Okay, now how do we integrate any further? Now, I'm trying to integrate Sech X. So I found that Sech X is equal to this. So then instead of integrating Sech X, I'm going to integrate this. Okay, are you with me? But once again, do you think any of the rules work? F dash X over Fx? Do I have the differentiation of the denominator on the numerator? Check properly. E2x differentiation, is it there? E2x differentiation is 2 e to the power what? 2x. Do I have e to the power 2x on top? If I have e to the power 2x, because e2x is 2 e to the power 2x, the differentiation. But I have 2, I have ex, I don't have e to the power 2x. Okay. So then what we do here is the f dash x over fx rule will not work. Okay, it will not work. So we need something else. So we are going to use in this case a substitution. You remember in P4 integration by substitution? Okay, so let's do it. Let's say let u be equal to ex. Input the substitution, let u be equal to ex. So if u is ex, what's the next thing we do? We must differentiate the given substitution, right? So we get here, let's differentiate du by dx is equal, ex differentiation is ex. So then you know that we are trying to get rid of, when you are doing a substitution, when we turn it to u, the whole sum needs to be converted and written in terms of u, right? So dx also, let's substitute the value for dx. So we get here du equal ex times dx. Do you agree? So I get ex equals du over ex. Do you agree? So this is my substitution for dx. Let's substitute now. So let's go back to the sum, integration of Sech X. I have 2ex over e2x plus 1 times dx. So let's input the values. 2ex. First, I'm not going to replace these people immediately. So dx is now replaced as du over e to the power x. What happens? The ex will cancel out. So I end up getting here 2 over. Now I need to convert this sum to u. So who will be e2x? If u is ex, then e2x is u square. So basically this becomes 2 over u square plus 1. So we get 2 over u square plus 1. You can take the 2 out and we can get 1 over integration 1 over u square plus 1. Now go back to our integration rules. So I have brought the rules here. So out of these rules, which integration rule are we using with respect to u? 1 over u square plus 1. We can use rule number 9. 1 over 1 plus x square. So 1 over 1 plus u square. So can you see? So keeping the 2 out, I get here rule number 9. It's going to give me arctan u. Okay, plus c. Now finally replace the u. So when you replace u, we get 2 arctan ex plus c. Okay, so this is the technique that we use to integrate our Sech X. So you must know about this integration technique also. Okay.